In this video, you'll learn how to configure and run a hardware debug session in Microsoft Visual Studio Code. Assuming you have opened the project from the previous video, let's first start by creating a launch configuration. Click the Run and Debug group or use the keyboard shortcut. Click the link Create a launch.json file. If prompted, select your workspace from the list and select the MPLAB debugger. In the .vs code folder, a configurable launch.json file will be created. Let's, for example, set stop on entry to false, so that execution will not stop at the start of main. Connect the Curiosity board to your computer using the USB cable and verify that the green power LED is illuminated. Click the MPLAB group and confirm that the tool is shown in the Tools view. Open the main.c source file. Use the keyboard shortcut to go to line 109. Then click in the left margin to add a breakpoint. Launch the debug configuration from the Run and Debug group by clicking the green arrow or by using the keyboard shortcut. Select the Curiosity Nano tool if prompted. The program should halt at your breakpoint in main. In the Run control strip, execution can be controlled using the buttons or their keyboard shortcuts. Hit F5 to continue, and with the application running, you should see the state of the yellow LED toggle. Hit F6 to halt execution. In the breakpoints view, click the checkbox to disable our breakpoint. Go to line 133 and add another breakpoint here. After resuming execution, press the Curiosity board button next to the yellow LED and execution will halt at our new breakpoint. We'll now explore some debug views, such as variables, which will show the content of local variables in scope, and CPU registers implemented by your selected device. You can also monitor the call stack, showing the hierarchy of active functions. In Watch, you can monitor the content of any object. To add a watch, move your mouse pointer over the watch view. Click on the plus sign, type the object name or expression, and hit Enter. Or you can right-click an object symbol in any source file and select Add to Watch. The state of I/O pins and registers can be viewed and manipulated in real time while debugging the application. To start the I/O view, enter the run command MPLAB I/O view show. In the I/O view search bar, type Group 0 out to focus on the port's Group 0 I/O pins. Disable all breakpoints and ensure the running application is blinking the yellow LED. Pause the application. In the I/O view, red boxes are used to indicate changes in value. Click on bit 23 of Group 0 out and you will see the board's yellow LED toggle. To observe memory, set a breakpoint at line 163 in main.c and resume execution. With the program running, press the button on the board to have the program halt at this new breakpoint. In the Variables view, right-click on UART Local TX Buffer and select Show in Memory Inspector. The Memory Inspector opens at the address of this object. Click on the cogwheel in this view, expand Columns, and ensure the variables and ASCII boxes are checked. Expand Memory Format and change the bytes per MAU to 4. Click and hold the Memory View Title tab and drag this to the bottom of the Editor view, allowing both source and memory to be viewed concurrently. Resume execution, then press the button on the board. When the application halts, the contents of the array is updated. Start the data visualizer by entering the run command mplab data visualizer. This tool shows changes in your key data points during runtime, such as the output from the virtual COM port, which we'll demonstrate here. Find the virtual COM port used by the board, noting that host operating systems use different names for this port. Click on its cogwheel to confirm that the settings are those shown. Click the play button to start capturing, selecting Send to Terminal if prompted. In the terminal view, you will see output from the board. Click the button on the board to see the printed message change. Click the Stop button when capture is no longer required.